Lesson 12.3, Geometric Series. How do you find the sum of a geometric series? 1, you could add up all the terms. And if you've only got a few terms, that's not too bad. That's not too bad a way to do it. What if you've got like 100 terms? Then you might want to use a formula. And the formula is S sub n equals A times 1 minus r to the n over 1 minus r. Those are r's. Those are supposed to be r's. I can do a little bit better job than that. 1 minus r to the n divided by 1 minus r. All right, so let's try this. Investigating a geometric series. A series is an expression formed by adding the terms of a sequence. If the sequence is geometric and has a finite number of terms, it is called a finite geometric series. In this Explorer, you will generate several related finite geometric series and find a formula for calculating the sum of each series. We're going to start with a rectangular sheet of paper and assume that it has an area of 1 square unit. Cut the sheet in half and lay down one of the half pieces. Then cut the remaining sheet in half and lay down one of the quarter pieces, as if rebuilding the original sheet of paper. Continue the process. At each stage, cut the remaining piece in half and lay down one of the two pieces as if rebuilding the original sheet. B. Complete the table by expressing the total area of paper that has been laid down in two ways. 1, as the sum of the areas of the pieces that have been laid down, and 2, as the difference between one and the remaining pieces. All right, so sum of the areas of the pieces that have been laid down. Stage 1, first you lay down half. You cut the other piece in half, and then you lay down 1/4, and you had 3/4. Well, you lay down the quarter, and then that other quarter half, you cut it in half, and that was 1/8. And then you add these up, and you get 7/8. Well, that 1/8, you cut it in half, and then you lay that down, and you got 1/16, and this adds up to 15/16. Difference of 1 in the area, well, 1 minus 1/2, that was that other half of that sheet of paper. Well, cut that in half, and then you lay down 1/4. So you had like 3/4. Cut that in half, and you have 1/8, and then that's 7/8. Cut that 1/8 in half, and that's 1/16. And what do you have left? 15/16. Gets closer and closer, but it doesn't ever actually get there. We call that converge. It converges on. Write the sequence formed by the area of the individual pieces that are laid down. What type of sequence is it? Well, what was the first piece that we laid down? That was 1/2. And then the next size was 1/4. And then the next size was 1/8. And then 1/16. And if we did it again, it would have been 1/32, and so on and so on and so on. We call this a geometric sequence, and the R is 1/2. In the table from step B, you wrote four related finite geometric series. 1/2, 1/2 plus 1/4, 1/2 plus 1/4 plus 1/8, and 1/2 plus 1/4 plus 1/8 plus 1/16. One way you found the sum of the series was simply to add up the terms. Describe another way you found the sum of the series. Well, what was the other way? The right side of the table. We took 1 minus 1/16. That was the last piece that was laid down. And we said that we had laid down 15/16. So we subtracted the last term from 1. In the process of cutting the remaining pieces of paper and laying down one of the two pieces is continued. If the process of cutting the remaining piece of paper and laying down one of the two pieces is continued, you obtain the finite geometric series 1/2 plus 1/4 plus yada 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 plus 1/2 to the nth power at the nth stage. Use your answer to the previous question to find the sum of the series. Well, if our last term, remember, 1 minus, and our last term is here, that would be 1/2 to the nth power. Deriving a formula for the sum of a finite geometric series. To find a general formula for the sum of a finite geometric series with n terms, begin by writing the series S of n equals a plus ar squared plus ar to the third plus yada yada yada, ar to the n minus 1. Find the expression for r times s of n. R times s of n would be r times s of n equals a times r plus a times r squared plus a times r to the third, and then so on and so on, plus ar to the nth power. Find an expression for s of n minus r times s of n by aligning like terms and subtracting. So s of n equals a plus ar squared plus, and so on and so on and so on. And then r times s of n equals ar plus ar squared plus, and so on and so on, ar n minus 1 plus ar. So s of n equals, or s of n minus r times s of n equals, if you watch, this cancels out, that cancels out, this cancels out, those cancel out. What do we have left? We have a plus, and then, like I said, that canceled out, so that's a 0. This canceled out, so that's a 0. The ellipses, they cancel out, a 0. And then those. So we end up with a minus ar to the nth power. That's what we end up with. I'll put that back there. A minus ar to the nth. That's what we ended up with. Factor the left and right sides of the equation in step C. So S of n, 1 minus r, equals a times 1 minus r to the n. Divide both sides of the equation in step D by 1 minus r. So we're just moving this over here. Let me take this over here. S of n minus r times S of n equals a times or a minus ar to the n. And that doesn't really show what they're really doing here. So they're factoring out the s of n, and that leaves 1 minus r equals, and here, what are they factoring out? They're factoring out the a, and that leaves 1 minus r to the n. Okay, now they're going to divide both sides by 1 minus r, and they get s of n equals a, and then times 1 minus r to the n, and then 1 minus r. So that's what they really did, and that's how they end up with 1 minus r to the n. Pretty neat, isn't it? Oh, I should have. Oh. So, and there's your formula. There's your formula, and that's how they get it. 4. Reflect. Check to see if the formula in step E gives the same result as the answer you wrote in Reflect 3. Okay, so what is A? A is 1/2. R was 1/2. So the S of n equals 1/2 times 1 minus, and that was 1/2 to the n over 1 minus 1/2. And we can do a little arithmetic in here. And we have 1/2, and then 1. That can't do anything there. And then 1 minus 1/2 is 1/2. Now, if you'll notice, this here and this here cancel out, and you're left with 1 minus 1/2 to the nth power. So, eureka, they agree. They agree. What restrictions are there on the values of r that can be used in the formula for the sum of a finite geometric series? Explain. Well, look, you got one here in the denominator. Okay? You got 1 there in the denominator. So r cannot equal 1, because if it does, that would be 1 minus 1, which would give you 0. And let's see, because r equals 1 would result in a 0 in the denominator. And the 0 in the denominator is undefined, cannot divide by 0. So you can't have a 1. Finding the sum of a finite geometric series. The formula S of n equals a times 1 minus r to the nth divided by r, 1 minus r. For the sum of a geometric series requires knowing the values of a, r, and n. Recall that you learned how to find a and r for a geometric sequence, and the technique is no different for a series. A is the value of the first term, and r is the ratio of any two successive terms. To find n, you simply count the number of terms if they are all listed. For instance, for the finite geometric series 3 plus 6 plus 12 plus 24 plus 48, you can see that a equals 3, r equals 2, and n equals 5. If some of the terms of a finite geometric series have been replaced by an ellipse, as in 2 plus 6 plus 18 plus yada yada yada, plus 1,458, you obviously can't count the terms. One way to deal with this situation is to generate the missing terms by using the common ratio, which in this case is 3. 6 divided by 2 is 3. 18 divided by 6 is 3. So you've got it. The next term after 18 is 3 times 18, which would be 54, and repeatedly multiplying by 3 to generate successive terms gives 2 plus 6 plus 18 plus 54 plus 162 plus 486 plus 1,458. So the series has 7 terms. Another way to find the number of terms in 2 plus 6 plus 18 plus yada 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 plus 1,458 is to recognize that the nth term in a geometric series is a times r to the n minus 1 for the series 2 plus 6 plus 18 plus yada 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 plus 1458, whose nth term is 2 times 3 to the n minus 1. Find n as follows. So basically, they just use the formula. Remember the formula, f of n equals a r n to the minus 1. So they put the 1458 in for that. 1458 equals, and then the a, well, that's the first term. That's the 2. The r, that's just 6 divided by 2, right? That gives you 3. So they just put 3 in there. And then n minus 1. Set the nth term equal to the last term. All right. So we're just going to divide both sides by 2. And we get 729 equals 3 to the n minus 1. Now, we have to have a common base. So 729, that's 3 to the 6. And then times 3 to the n minus 1. Remember, if you have a common base, you can get rid of that. And you got 6 equals n minus 1. Add 1 to both sides, 7 equals n. So that's all they do there. Find the sum of the finite geometric series. You've got 1, 2, 3, 4, 5. You got 6 terms. It might be quicker to just add them all up, okay, than to do all these different calculations. But that's probably what I would do, is just add them all up. But find the values of a, r, and n. A is the first term, so we'll say a is the first term. A is the first term. And then find the common ratio. Well, that would be, they did 15 divided by 5. You could do 45 divided by 15. That would give you 3. You could do 135 divided by 45. That would give you 3. You could use any ones that you wanted to, and that would give you. And then they just counted them up. 1, 2, 3. I'm going to use red there. Yeah, 1, 2, 3, 4, 5, 6. So that's how they got 6. All right. And they're just showing you how to use the formula here. Use the formula S of n equals a times 1 minus r to the n divided by 1 minus r. So they put 5 in for the a. They put 3 in for the r and 6 in for the. Do a few calculations in the calculator, and there you go. All right, B. Now we get to do one. The first term in the series is a, and that is 1/4. So we're going to put 1/4 here. Find the common ratio by dividing two successive terms. 1/8 divided by 1/4. 1/8 divided by 1/4. That just gives you 1/2. So the nth term, 1/4 times 1/2 n minus 1 equal to the last term to find n. So 1 equal, and what was the last term? 1, let's see, the last term was, the last term here is 1 divided by 512. 1 divided by 512. Multiply both sides by 4. And they're doing that right here, multiplying that by 4. And of course, they multiply that by 4. And they get some more. And that's just to get rid of that right there. And you have 1/2 over 1 over 128. Now you need to write 1 over 128 as a power of 2. Okay. And I think that is, let's see, 2 to the 6. Is that right? 2 to the 6 is, that's 64. So 2 to the 7th is 128. So that's 1/2 to the 7th power, right? And then add, now you can get rid of your bases, and you have n minus 1 equals 7. And then let's see, we had n minus 1 is 7. Add 1 to both sides, so n equals 8. Use the formula S of n equals 8 times 1. I guess now we're going to solve. So what was A? What was A? What was the first term? 1/4. And then R was 1/2. And then we found n to be 8. So 1 minus 1/2. So that would be 1 over 256. 1 over 256. Need to move it up some. 1 over 256. 1 minus 1/2. That just gives you 1/2. 1 minus 1 over 256 is 255. I have a little 255. Okay. 255 over 256 divided by 1/2 is 255 over, and then what is half of 2? That's 128. And so 1/4 times 255 over 128 would be 255 over 512. Pretty cool. Your turn. Find the sum of the finite geometric series. Now, like I said, how many terms you got here? 1, 2, 3, 4, 5, 6. Really, I would just, if it were me, I wouldn't use the formula. I would just add them up and then get whatever it is. That would be quicker. But let's practice the formula. So let's see here. We're going to start off with A. What is A? A is the first term, and that's going to be 1. R is, well, let's see, -2 divided by 1, that gives you -2. So, and again, -8 divided by 4 is -2. -32 divided by 16 is -2. So R is -2. And then N is 1, 2, 3, 4, 5, 6. N is 6. So N equals 6. Now, why am I finding all of these? Well, what is the formula? S sub n equals A times 1 minus R to the nth over 1 minus R. Okay, so I'm just finding all the pieces that I need for this equation. So S to the 6, or S of 6, that's going to equal A, which is 1, times, let me fix that, 1 minus 1 minus, and then 1 minus r. R is -2 to the nth power, which is 6, over 1 minus r, which is -2. Now, I would just plug all that in the calculator, and let's get a calculator here. Calculate. So, yeah. 1, open parentheses, control divide, 1 minus, open parentheses, -2, close parentheses, caret, and that was 6, right? All over, and then 1 minus 1, control divide 2, and check our formula. 1 times 1 minus -2 to the 6th power, 1 minus, and I put 1/2 there. I just about messed that up. And that was open parentheses, -2, close parentheses. And then, good thing we checked our formula, huh? Or check to make sure there we go. So we get -21. So this equals -21. And let's check. Let's just check our series here. We had 1 minus 2, and then it was +4 minus 8, +4 minus 8, and then +16 minus 32, and we'll hit enter. -21. It works. It gives you the same thing, which is what you want. What about number 7 down here? All right, stop the video and try this on your own first, and when you come back, we'll do it together. Glad you're back. A equals 1/2, and then R equals, and that's going to be -1/4 divided by 1/2. -1/4 divided by 1/2, that's going to give you -1/2. And then n equals, whoa, we don't know what n is, do we? So we're going to have to find n. How do we find n? Well, let's go over here and let's see, what do we got? We've got f, or s of n. S of n equals, no. We've got f of n equals ar to the n minus 1. So f of n is -1/256, and then a is 1/2, and then r, that was -1/2, and then n minus 1. So the only thing we don't know is what is n. What is n? I think first we're going to multiply everything by 2 so we can get rid of that 1/2, and then we'll multiply that by 2. So this cancels out and that cancels out, and you're left with -1/2 n minus 1. And then in here, you're going to have -1/2 was 128, -1/128. Okay, so let's see here. 128, we did that a minute ago. So this is going to be -1/2, -1/2, and to the 7th power. And this is going to be -1/2 to the n minus 1. Again, we have a common base. So now we can solve for n. We have 7 equals n minus 1. Add 1 to both sides, so 8 equals n. All right, good. So now we found our n. We can put an 8 in there. So S of 8 equals, and then A is 1/2 times 1 minus R is negative 1/2 to the 8 minus 1, or the 8th power, all over 1 minus negative 1/2. That looks terrible, doesn't it? 1 minus negative 1/2. And make my parentheses a little bigger here and a little bigger there. So we have 1/2, and in 1 minus, and then to the 8th, that's going to be 1 over, that's going to be negative 1 over, well, since you're doing it like that, that's going to be 1 over, and then that's going to be 256. And all over, well, that would be 1 plus 1/2. So that's going to be 1 plus 1/2. All right, so that's going to be 255 over 256. That's 1/2 is still out there. And that is now going to be 3/2. 3/2. And so you got 1/2, and then do a little trick there. And then you're going to have 85 over 128. Then that's going to give you 85 over 256. Okay, that's pretty tricky stuff. So I think we would check that with the calculator. So what was our thing? We had 1/2, right? Control, divide, 1 over 2, and then we got open parentheses, control, divide, and then we had 1 minus open parentheses. That was negative 1/2, negative 1/2, negative 1, control, divide, 2. And let's get caret, and then 8 was in. So let's go down here, and you got 1 minus open parentheses, negative 1, control, divide 2. And let's check and make sure we got everything right. So you got 1/2 times 1 minus 1/2 to the 8th over 1 minus 1/2. And then let's hit enter. 85 over 250, is that what I got? 85 over 256, good. That worked out real well. And solving a real world problem involving a finite geometric series. Some financial problems can be modeled by a geometric series. For instance, an annuity involves equal payments made at regular intervals for a fixed amount of time. Because money can be invested and earn interest, comparing the value of money today to the value of money in the future requires accounting for the effect of interest. The future value of an annuity is how much the annuity payments will be worth at some point in the future. The present value of an annuity is how much the annuity payments are worth in the present. Although an interest rate is typically expressed as an annual rate, it can be converted to a rate for other periods of time. For instance, an annual interest rate of R% results in a monthly interest rate of R divided by 12%. In general, if interest is earned n times per year, an annual interest rate of R% is divided by n, the number of times it is done over over the course of the year. Like if it's monthly, it would be R divided by 12. If it's quarterly, it would be R divided by 3. Now, I'll let you read A, and you can follow along. And then when you get back, we'll do B together. All right, glad you're back. Let's do B here together. Niobe decides to postpone purchasing a new car because she wants to get a new smartphone instead. Priorities. She can pay the phone's full price of $580 up front, or she can agree to pay an extra $25 per month on her phone bill over the course of a 2-year contract for phone service. What is the present cost to Niobe if she agrees to pay $25 per month for 2 years, assuming that she could put the money for the payments in a savings account that earns 3% annual interest rate and make $25 monthly withdrawals for 2 years? As in Part A, a 3% annual rate becomes 0.25% monthly interest rate. And the way they got it, 3 divided by 12. Okay, and that's 1/4, which is 0.25. And you could say 3%, and then that would give you 0.25%. All right. If Niobe puts an amount M1 in the savings account, M1 in a savings account, and lets it earn interest for 1 month, then she will have M1 plus 0.0025 M1, or 1.0025 M1 available to make her first phone payment. Since she wants 1.0025 M1 to equal $25, she must M1 must be equal 25 divided by 1.0025, which is approximately $24.94. This means the present cost of her phone payment is $24.94, because that amount of money will be worth $25 in 1 month after earning 0.06 cents or 6 cents in the interest. Similarly, if Niobe puts an additional amount M2 in the savings account and lets it earn interest for 2 months, then she will have 1.0025 M2 after 1 month, and 1.0025 times 1.0025 M2, or 1.0025. See, that's going to be squared M2 after 2 months. Since she wants 1.0025 squared times M2 to equal $25, M2 must equal $25 divided by 1.0025 squared. And if you put that in the calculator, it gives you $24.88. This means that the present cost of her second phone payment is $24.88. It also means that she must deposit a total of M1 plus M2, which is $24.94 plus $24.88, and that equals $49.82 in the savings account in order to have enough money for her first 2 payments. So the first payment is $25 divided by 1.0025, and then that twice. This would be 3 times. So that would be to the 3rd power, and keep on and on and on. And then over the 2 years, you would add all of this up. Now, find the sum of a geometric series that represents the present cost of 24 payments. So 25 divided by 1.0025 equals R time, let's see, what is R? R is going to be 1 over 1.0025. That's going to be R. N is going to be 24. So the sum of 24 would be 25 divided by 1.0025, and that's going to be 1 in R. That's going to be 1 divided by 1.0025, and it's 24 months, and then 1 minus 1.0025. Okay. Although Niobe will end up making $25 times 24, that's going to be $600. The present cost of the payments is $581.85, which is only slightly more than the upfront price of the phone. What was the upfront price of the phone? What was the upfront price of the phone? The upfront was $580. So she's paying more. She's cell phone companies, they're not doing anything for free, are they? Lottery winner. A lottery winner is given the choice of collecting $1 million immediately or collecting payments of $6,000 per month for the next 20 years. Assuming that the lottery money can be invested in an account with an annual interest rate of 6% that is applied monthly. Find the present value of the lottery's delayed payout plan in order to compare it to the lump sum plan if you decide which plan is better. Okay, couple things. What do we need? Well, the monthly interest. Now, that's 6% divided by 12 months. That's going to give you 0.5% or 0.005. Yeah, move that over too. All right, good. Well, the first month. What do we got? We're going to get $6,000, and the interest is 1.005. And if you put that in the calculator, that is approximately $5,970.15. That's the first month. And then, let's see, the first and second. I'm having some little bit of my handwriting is terrible enough. This thing here does not need to be messing me up. I don't know what's going on. 1 and 2 months. Let's give it a second. I wish whatever Windows is doing it'd stop. So that would be 6,000 over 1. Come on. 1.005 plus 6,000. 1.005, and that's going to be squared. So and if you put those in your calculator, that's going to come up to approximately $11,910.66. Okay, that's the present value of 2 payments. Well, what would be the present value, of say 24 months, or not 24 months, but it said well, that would be 240 years, 20 years, 240 months. Okay, that's going to be 6,000 over 1.0. Come on, 0.005 plus 6,000 over at 1.005 squared, and then let's see, plus 6,000 over, that's going to be 1.005 to the third. And I don't think I need to write all of these out. Plus and then we'll do the last month. That would be 6,000, and that would be 1.005. See how it's jumping around there? Golly. 1.005 to the 200. Come on. This is aggravating. 240. Okay, so that would be does that not look like a geometric series? It does. It does. So what is A? Let's see what A is. A is our first term, which is 6,000 over 1.005. What is R? R, what is R? That's the 1.005. That's how much we're growing or depreciating. And then our term N is 240, and I got that by 220 times 12 months gave me 240. So that's how I got all that. Now, so S of 240 S of 240 equals, and then we got A, that's going to be $6,000 a month divided by the interest, 1.005, and it's going to be times, you have 1 minus, and then 1 minus, and then R is going to be 1 over 1.005 to the 240th power, and then 1 divided by 1 minus 1 divided by 1.005. And folks, does that look like a calculator problem to you? That looks like a calculator problem to me. So let's go to our trusty rusty calculator, and we'll put that in. So we've got control divide 6,000, 1, 2, 3 over 1.005. And then we got open parentheses, and then inside that control divide, we got 1 minus, and then open parentheses, we've got 6,000, control divide, let's put 6,000, and that's not right. R was 1 over 1.005, and then caret 240 was the length of the term. And then down here we got 1 minus control divide r, which is 1 divided by 1.005. Let's check our equation. 6,000 divided by 1.005. 1 minus 1.005 to the 240. Then 1 minus 1.005. All right, n. So we get 837,485. And let's see, doc. 7. That's not what I wanted. Document settings, yeah. Float 6. We'll just put it on float. Make default. Okay. So let's go up there and grab that. Okay, so $837,484.63. Pretty cool, huh? So $837,000 and 484.63. So that's really, if you take the annuity, and given you're able to get 6% interest, you might be able to get more, you might get less. It just kind of depends. Over the next 24 or 20 years, that's how much that $1 million is worth. So, an alternative way of writing the formula for the sum of the finite geometric series is S of n equals a minus r times ar to the n minus 1 power over 1 minus r. Describe in words how to find the sum of a finite geometric series using this formula. So we got to describe this, how we're going to do this using words, put it into words. So find the difference. Find the difference of the first term and the product of r and the last term. Divide the difference by the difference of one and r. Now that can be written several different ways. So if yours isn't just like mine, that's fine. Describe how to find the number of terms in a finite geometric series when some of the terms have been replaced by an ellipse. Well, remember, you might want to use that f of n equals a r to the n minus 1 formula, because the nth term of a geometric series is AR to the n minus 1. Set this equal. Set this equal to the last term. And solve for n. When analyzing an annuity, why is it important to determine the annuity's present value or future value? Why is that? Well, payments occur over time. The value of each of these payments changes when the interest earned is taken into account. So, like they showed you, well, on the cell phone, it says, the cost is $580. Okay, that was the cost. If you paid $25 a month times 24 months, let's see, what does that give you? 25 times 24. How much is that? Well, that's $600. 25 times 24, that's $600. Okay. Now, what's the difference between 600 minus $580? That's $20. That's the interest they're charging you. That's the interest they're charging you. Wouldn't it make sense to see how much interest you could generate? How much if your savings account was getting 3%, which that's pretty average, if your savings account is getting 3%, how much would you have to put in? How much would you have if you invested it? And we came up and it was like $581. Okay, 581, and there was some change. So if you were putting that money into your account, what would it be? And so really, they're charging you $20, but it's spread out over the years. Really, instead of paying the $580 up front, you're spreading $581 over the 24 months. So the interest that they're really charging is not $20. The interest that you're actually losing is only $1. So that might not be such a bad deal. This concludes lesson 12-3. Enjoy your evening.